Hey, how are you?
I'm doing good.
Hey. Can you hear me?
Yeah, I can hear you. Can you hear me?
Okay, good. Yeah, I can hear you.
So for today, we are going to do a data structure algorithm interview, right?
Yeah,
Okay. So I want to go to the code point. Have you taken any mock interview in the past, or is it your first
yeah,
one? Okay,
yeah,
you
I
have,
have.
yeah, yeah, okay. So I want to share a problem with you, and then please take a look at this problem and let me know if you have any questions.
Okay.
Uh,
Do I need to share my screen
yeah, that would
also?
be helpful when you go to the code point. Please share your screen with me.
Okay, I think I'm sharing right now.
And you are doing with Python, or is it?
Yeah, Python.
Okay, great.
Well, I'm not. Well, I'm not that good because I know that Python is probably easier for or good for interview because it can help write code quickly. So that's why I'm also learning Python. It's not that I'm not expert on Python. So yeah. Let's see. So 6. Let's try what's got. So I'm trying to think of. I'm trying to think of an algorithm. So, for example, I'm looking at the example two. For example, if I'm given a string of digit um, and I know that the mapping of A to Z. So if I'm looking at the first if I'm scanning from left to right
Okay, yeah.
for that input, then I could have two choices based on the mapping I'm given, like A to Z, because I can either it can either map to 2 or it can either map to 22.
Yeah, that is true. Mhm.
And then once I have that, then um, I can I can recursively pass the remaining string. So let's say the first I can choose 2, and then the next remaining, if I do it recursively, the remaining problem will be 2, 6, and I can just instead of passing the remaining substring, I can just use the passing the position of the next of the beginning position of the remaining substring to the subordinate, the subproblem. And then another alternative is I can pick the first 2 digit, which map to in this case 2 is mapped to B, right? And then I pass to this. So let's say let's do this way. Okay, so this is like index equals 0, for example, and this is input string S. So I can, so there are 2 options. Either I pick the first digit, or I pick the first 2 digit, and
Yeah.
other options. So this will be whatever YC W. I think it's W, and then I pass in. So this will be, and then I call F, I think so it's still S, but then the index will be equals 1. And then what is this? S and then index 2, because I choose the first 2 digits, and then the subproblem will be evaluate at the remaining input indicated by the starting index 2. So in this case, that will be that will actually be the S is 2, 6. So and I can do the same thing again. So the first choice will be 2, and then second choice is 2, 6. So this will be B, and the remaining problem 2, and then this is Z. Then this is actually so this will actually, whenever the index is beyond our bound, like traverse to the end, then we can exit. So that is the base case. So so basically, but I need to actually accumulating the count, and then so this is go one more. So if this will return 1 back 1 3 3. Okay. So this is 1 more. So there's only 1. So the base case is either I go out of the length of the array, or we reach the end.
Okay. Okay.
Yeah. In this case, this case reach the end of the end character, the end input, the end digit of the array. So there's only one choice. So this, okay. Here, 2, 6, 26, or 2, 6, or 22, 6. Yeah, this is 6. Okay, 2, 6, 26, 6. Yeah. Now I'm trying to think about the returning the total count out.
Yeah, exactly.
Let's see. So basically, I just need to when I reach the end node, I just return. I just return like one. So if I'm reaching the
Okay, so you are returning one when you reach to the end, right?
yeah, and
Okay,
then
that
it
looks good to
just
me, I think.
yeah,
Okay.
it's just like bubble up. So if the parents see there's two child, whatever that return, it's just like sum it up and then return upstream. So I think it's just the parent will just need to sum up whatever is returned from the child. And I think in this case, in 226 case, yeah, you will see it will end up like returning 3 back. I think that is the approach. Yeah. So I guess maybe. So is there anything?
I think that looks good to my opinion. You have the good idea about the problem. Maybe you can start to code this out
Okay.
if you want.
Okay. Cool. See. Okay. So I think. Oh, that's a function. Okay. So find depth. Find. So base. So you have a array. So this is what and I'm going to have helper function. Start with index 0. Actually, this would be turning total count. Then total count. So this now that's so what is the base case? If so, this is the base case. If index goes to length minus 1. Let's see. Let's try to let's try to get to the recursive first. So there are two cases. So I would say equals say L array 2, 3, 4, 5, 6. Okay. Array. This will be like if I'm looking at like the first. This is one choice. I'm just picking the one digit at the current index. Right. Yes. Plus 2. See. Let's see if that's the case. I think there's some edge case. I think maybe I can take care of. Well, I could take care of some edge case here. So if the array size is 1, then we can just return it 1. So that I don't need to handle the edge case this because like if the array is length is 1 and then I increment index by 2, then it will be just overbound. So I can just handle edge case here.
What is the edge case?
Well, so I want to start at least in the helper function like the array having a size of 2. So because if the array size is 1, I guess maybe let me see. I think this can be. I think maybe I can do this actually. If index is go beyond because it could go if I increment by 1. Okay, it could be at the end, but then or it could be if I'm the second last digit and then increment by 1. Okay, then I reach the end of the character digit. But then if I am increment by 2, then I just go beyond it. So in both cases, I just return 1.
Yeah. Okay.
So I think that probably more clean. Is that let me see that okay, is that it? No, let's see. I can just maybe do some dry run.
Yeah, that is good. Maybe you can do a dry run.
Yep. See. Okay. So let's pick. Why don't we pick example 2 for dry one? So 2 to 6 input, and then index is 0. So index is not greater. Length array is length array is 3. So the base case is false. Then I go to the recursive. First recursive is is 1. And this is 2. Okay, and this is still base case still 4th. So I do another this is 2. Why don't I put this? It's hard to. Maybe I put this is. Okay, I try to. So this is the first level, first recursive. So I'm going to here, and then this should be 2 or plus 3, and 3. Okay, I think maybe so this will be actually to actually 1, 2. Actually, if I reaches the end, actually I want to return 1. Because because if I reach to 2, then that means in this recursive function, I'm reaching the end of the digit. So there's only one choice, and that's what I want to return as base case. So this is actually return 1. I want to return 1 of this, and then I return 1. So I will go to the next recursive. This case is 3. See, if I go, oh, actually, you know what? 1, 2, 6. This is 1 and 3. Yeah, so this one go beyond it. So 1. And then both of this return 2. So both of this will return both of this will return 2. 2 equals this 2. And then this one. Let me see what's this. This is 2 0 1 2. And then this one, it reaches the base case because length of array is 3 minus 1 is 2, and then index is 2. So this one actually return 1. And so I have 2, which this helper will return, and then this helper return 1. So the total is 3. So I think that will
Yeah,
work.
that is good. What do you think if you have 106, what's going to happen?
106. Let me see. If you have one, if you have an example, maybe that may not work. I think. So array equal 106. So I can choose 1 or 1 0, and then the next one, oh yeah, I cannot choose 0 because 0 is invalid. So I need to check. So that means that means I need to check the invalid. If this is if this is not bad, so for this case, 1, and then that means the helper will have array and index will be at 1, and that is actually, yeah, that is not valid because I cannot choose 0, and I cannot even choose 0, 6. So so if I hit if I hit a invalid choice, then I should
What should
just
you do?
backtrack, return 0,
Okay.
because there shouldn't be any option to choose, right? So that means I need to add some. So I need to actually check the array, the value. So if I'm doing, so that means before even I go to base, then I should do the check. This is kind of like a backtrack. So if that's array and array, yes, goes to 0, and I should just return 0. Is that what? Let's see. Array index equals 0. So if I get, so let's see if, so for example 3, in this case, I just return 0. So so that work for example 3, and then in this 106 you provided, I pick 1 and then go to the helper functions, and then call recursively, and then recursively actually I will hit that backtracking case because the index is 1, and which is this one, and this is 0, so I return 0. So this whole thing will return 0.
Okay, so what is the condition that you have to add in order to take care of this?
That is the condition here. Yep. And then
Yeah, but the point is that if it is 0, or if it is something like, if you have, for example, 27, can you map it to something?
27, no.
Okay, are you checking somewhere here? Maybe I am missing this.
Oh, I see what you mean. So I see what you mean. So basically, we need to check any range outside of 1 through 26, basically, because that is the only valid mapping here, right? 1 through 26. So if I'm hitting any 0 or 26 or beyond 27, then that means I should just I should ignore that, right? I should ignore that and then
Okay,
just return 0.
sure, that is good. So what is the time? I'm fine with that. What is the time complexity of this algorithm?
The time complexity. So we are actually we kind of like recursively calling like every time uh, we are in this function, we potentially we have two potential choices in the worst case. So in this case, we could be looking at 2 to the power n.
Okay, that is
So
good.
that is the worst case, yeah.
What about the space complexity?
Space complexity will be just maybe the height of the tree, which is like log n, because you are just traversing. In this case, you are just traversing. In this case, you're traversing maybe one digit at a time. So this is like if there's an n, it already has n digit. So this will just go to the very bottom of the stack, which is the log, which is like the height of the tree, which is log n. And then you just because you turn it back, and then you just go to the next choice, the second choice helper. In any case, it won't be go beyond the height of the tree, which is
Okay,
log n.
great.
So
Okay,
yeah.
great. So what is that? What is the order of n or log of n?
The n is just like the length of the
Okay,
array.
so it is order of n. Is it clear, right? I just want to make sure it is order of n or log of n. Maybe I am not hearing it correctly.
Oh, sorry. The height of the tree. Oh, sorry. The height. The height is a n. Sorry, the height is
Okay,
n because there's a maximum. Yeah. Yeah.
so it is order of n, not log of n.
Yeah. Exactly. Order
Okay,
n. Yeah.
okay. Do you think that we can improve this?
That I guess it's possible.
Okay. What do you think that we can do?
So we could. Okay, I see. So this looks like the subproblem we computed. Some of the subproblem we computed. Like for example,
Okay.
in 226, for example, we may hit like we compute with two times,
Okay.
and
So
6 is a 2
what is
times.
the solution for that?
We could we can apply using some dynamic programming approach.
Okay. Sounds good.
Yeah.
That is good.
So
Great. So let me spend some time to share my feedback in the interest of time. Yeah, I think
okay.
your problem solving is very good. I was very happy with that. You came up with all the necessary observation for this problem to use recursion, and at any level of the recursion, you have two choices: either take 2 digits or 1 digit, and then recurse. And the last observation is that how to count this when you reach to the end of the tree or recursion tree, you can return a 1. Okay,
Yeah.
all of them were in your you came up with that, and I felt that you kind of converted into the code in a more efficient way. There are two issues that I wanted to call out. One of them is that it took you longer than expected, and that is partially because you are not still prepared. So that took you a while to, you started to start coding maybe after 30 minutes, roughly, or 25 minutes. So the second thing was that you kind of overlook an important condition of the problem, which is the validation of some of the string. So that was something that either you didn't read the problem carefully, or you just were not careful enough when you were writing the code. So that was a big miss. Okay, but other than that, everything else was good. Okay. So another issue on the time complexity, you did very well. Space complexity, as you mentioned, it is the height of the tree, which is could be as long as the length of the string, right? So it is not log of n, it is order of n. Okay. And we can improve that. As you mentioned, the problem here is that we have overlapping subproblems. So there are some substring that we compute over and over, and we can avoid that using two methods. One of them is memorization. The other one is dynamic programming. Okay.
Oh, yeah, right. Okay, yeah.
Okay, so that is my overall feedback. I'm going to write a feedback later, but that is a highlight of my feedback. So what I would encourage you to do is to definitely you need more practice. Overall pace of the development and coding should be improved. And make sure that if it is possible, you can do time space complexity before starting to code. If you can do that,
I see.
It would be helpful if you can do that. But it is not necessary all the time. So the good thing is that if you it helps you to it helps you to maybe provide a better handshaking with the interviewer. Maybe the interviewer, maybe your solution is suboptimal and the interviewer wants you to improve that. Okay. And also when there is a recursion, make sure that you think about the overlapping subproblem. And if there is an issue with the overlapping subproblem, maybe you have to use dynamic programming or memorization. Okay.
I see. So I think the miss that I have is basically checking the invalid condition that I missed. That's a big part, right?
Yeah.
I see. Yeah. And then
yeah. Anyway, so I think, as I mentioned, my point was that you were missing the validity condition. If it is greater than 26, you have to kind of stop that. Okay.
Right. That's right. Yeah. Exactly. Yeah. I missed that. Yeah. Thank you. And then so in this, I think I'm still rusty, which I know because it's too slow, like you said. But then in the actual interview, like instead of writing the recursive case, ideally I should maybe also think about this can be optimized further. To using dynamic approach before even I write anything, right?
Yeah, I think if it is okay, I think it would be nice if you can think about that beforehand. That is better, but still after the fact, it's also still okay. You can use memorization. If you use memorization, you could also make this optimal. Okay.
Okay. Yeah. I thought about that actually because actually I draw something here. I don't know, you didn't see it, but I draw something here.
No, that is fine. I
know
think I
there's
totally
some.
understand. Yeah. Okay, that is fine. I think no worries.
Yeah, when I draw that, I saw there's some overlapping subproblem, but then I kind of like maybe try to like maybe I should ask, maybe I should be more proactive to bring up, hey, I saw there's some overlapping subproblem, maybe we can even optimize further. I think that may be even better, right? That, like you said.
Okay. Yeah, that is good. I think that is good. You need a little bit more practice, but overall it was good.
Sure. Thank you very much.
Yeah. Have a beautiful evening and enjoy your weekend. Okay.
Yeah, you too. Thank you. Thank you so much for your advice. Thank you.
Absolutely.
Bye.